Welcome. If you are listening to this video, you have been assigned dataset 5. This does have a lot of information contained within it. You're going to want to pay close attention in order to really take in what is entirely going on here. In dataset 5, what we're ultimately looking at is how cancer kind of comes to be. We can see it starts up at the top here with the mutation somewhere in the gene of a DNA sequence. So the DNA, it changes, that's a mutation. After that mutation has occurred, cells go through mitosis and they proliferate or multiply really fast. As a result of this mutation having occurred here, the mutation is copied over and over again. So all of these cells that have proliferated have that mutation. Mutations can sometimes cause DNA repair to stop. Our DNA has built-in repair mechanisms because we have to make copies of DNA all the time. We spoke of, mitosis and cells creating new cells. So every time we create new cells, we have to create new DNA. There's going to be a lot of errors that kind of happen. Kind of like when you're writing words off the whiteboard, you might miss a letter or two here and there, and that happens with DNA when it's making copies. Well, in normal circumstances, there's a repair mechanism that would fix any mutation. However, some mutations can actually turn off that proofreading mechanism where the proofreading would no longer happen to make any corrections. Now, if this gene that were inactivated or turned off was a normal gene, that is a proto-oncogene. It's a normal DNA sequence. Proto-oncogenes are normal DNA sequence. When these become changed, they can become what is known as an oncogene. And an oncogene can kind of be like thought of as pre-cancer cells. So they're not cancer yet, but they're set up to become cancer cells. So a normal person has proto-oncogenes in their DNA, but after mutations, they would become oncogenes or pre-cancer cells. We can see that mutations continue to turn off these proofreaders, the tumor suppressor genes, which would prevent cancer from forming. It would fix mutations, but those are turned off. So no proofreading, mistakes get made, and if mistakes get made, then we have cancer cells that have arrived as a result of a mutation to one cell many steps back. So now that we have talked about the image on your page, let's talk about the reading here. We see carcinogenesis, which is also called oncogenesis. They are the same thing. Is the formation of cancer. So these is when cancer forms. Cancer is when normal cells, proto-oncogenes, their DNA is transformed into cancer cells. So the DNA in the cancer cells now would become one of those oncogenes. This process is characterized by changes at the cellular in the DNA, and genetic levels, DNA again, and also abnormal cell division. So these cells are going through mitosis quickly, and they're reproducing when they don't necessarily need to sustain a healthy individual. That would cause a tumor, by the way. Cell division is a process that occurs in almost all tissues and under a variety of circumstances. We talked about skin, which is a tissue, and a circumstance when cells would go through cell division, and skin would be when we get a cut. There are a few tissues that do not almost, that do not go through mitosis, like nerve tissue, which is why if you were to damage your spinal cord, you would be paralyzed likely for life, because those don't create new cells to replace the ones that were damaged. Normally, the balance between proliferation or formation and apoptosis, new word right there, apoptosis, which by the way means predetermined cell death. So our cells are born with a kind of expiration date in them, and they will die and they'll be replaced by new cells. So pre-programmed death, it is maintained, and it's done so to ensure the integrity or the quality of tissues and organs. We want to make sure that the tissues and organs have healthy, fully functioning cells, so that our bodies can perform and function at the highest level. According to the prevailing accepted theory of carcinogenesis, once again, formation of cancer, the somatic mutation theory, mutations in DNA that lead to cancer disrupt these orderly processes by disrupting the genes that regulate cell division. So when we're talking about genes that regulate cell division, we are really kind of talking about various forms of proto-oncogenes. They kind of determine when a cell starts mitosis, when a cell ends mitosis, so on and so forth is kind of determined by these sections of DNA. However, when those sections of DNA are disrupted, we form those oncogenes, and now we no longer go through standard proliferation and standard death, meaning that cells, they begin dividing, frankly, whenever they want, not when they're supposed to, and when a cell is supposed to die, they might continue to live. That might seem good if a cell continues to live, but keep in mind, as cells get older, they're exposed to more and more mutations. So more and more mutations they build up as a person gets older, as the cells get older, and those can accumulate, causing, frankly, more oncogenes. As a result, we have uncontrolled cell division because there's nothing like a proto-oncogene or a tumor suppressor to proofread to make sure that the DNA is correct, and that would lead to the formation of cancer. Your assignment is to answer this question right here and use evidence, i.e. data, that supports your claim. Now in your case, data will not be in the form of numbers, but keep in mind data is information, and all of this information up here could be classified as data.